So welcome. My name is Amit. I just recently started a new company called Zolo Labs, a Clojure datomic storm startup that's doing some fun stuff. Talk about that in a second. I used to run engineering at a company called Runa before that, and I've been using Clojure in production for about 4 to 5 years. I'm also the author of Clojure in Action, and it's going into its second edition, so maybe you guys can check that out. The first product that we're building at Zolo Labs is a sort of virtual assistant to help you with your professional networking and maybe personal networking as well. We're sort of building it for ourselves because I certainly suck at keeping up with people and staying on top of conversations and always seem to drop the ball on stuff. So this is sort of automating some of those things away. So you should check it out. It's not yet launched, but hopefully soon. Today, the topic of the conversation, of course, is domain-driven design. Sort of a disclaimer, we're not really going to talk a lot about it. Because, there's a lot you can talk about that particular topic. There's interesting stuff like bounded contexts and shared kernels and a lot of theoretical things that we can discuss in there, but it doesn't really make for a particularly interesting first talk at a conference. So I do recommend you guys read the book. It's really good, and it goes into some depth about some of the nuances there. But today, I'd really like to talk about how to organize larger Clojure applications and sort of some of the lessons I've learned over the last few years. The idea, of course, is that you want your applications to be sort of modular. You want it to be maintainable. You want to be able to scale up the team. Often if you're a startup, you start with 1 or 2 engineers, and you hopefully are successful enough that you ramp it up to dozens. And Clojure offers many things in the way of productivity, but not designing applications appropriately will result in suboptimal velocity. And so this is a kind of approach to mitigating that. It is not going to be a talk about something you can go tomorrow and start implementing. It's not a step-by-step prescription. It's really a way of thinking about things, a mental model, if you will. So when you do work on your day-to-day jobs, there's something you keep in mind. And very broadly, it's just that notion of keeping the business of your startup organization or your product at the front and center of everything you do. Obviously technology is important. Obviously, a lot of things that we do and have fun doing are important. But at the end of the day, you want to make sure that you're delivering what you set out to deliver. And that's really what the focus of this talk is about. So specifically, we're going to talk about 3 things. We're going to talk about domain, even though I said we wouldn't. We're going to talk about driven, and we're going to talk about design. So if you think about the first aspect of this, and if you're coming from the OO world, which many people are, I certainly did, you may be familiar with this concept of layered architectures and designing your applications in such a way that a layer builds on top of the other, it's decoupled, it's all the good things that you learn about and practice. So this is sort of a typical stack, if you will, a layered stack for a object-oriented application, right? You've got some sort of data storage, a layer of code that deals with that storage. You've got your business logic sitting in what you might call a domain. And then you've got some notion of your client-server sort of situation. You've got some notion of transporting information from the server to the client, and some data objects, or maybe some sort of an open representation, JSON, XML, etc., and a mechanism to do that. And then you've got a presentation layer on the client side. And each of these may have sub-layers. If you're doing a rich client, for example, your presentation layer may have an MVC pattern in there. Beyond these things, you also have a bunch of other things that you may want to include in your design and the architecture. You've got APIs that allow third parties to access the functionality that you're building. You've got multiple clients today. You might have mobile clients, you may have a desktop application, certainly a website. You may want to process data on a cron basis, or every other hour or whatever that your domain requires you to do. You may want to process stuff in real time as it comes in from some external system, right? You may have offline modes. I mean, whatever. There's a whole bunch of other stuff that is not necessarily part of this, but you have this ecosystem of things that you've built around your app. What we're going to talk about today, again, is this business logic layer. Okay, so let's talk about that a second. What is the domain, right? A domain in general is sort of a subject area, if you will, right? It is essentially what differentiates your application from another application. And in fact, it differentiates applications in the same domain. The quality or the specific nature of your business logic will differentiate competing applications from each other as well, right? This is where you sort of leverage the expertise of your business folks, your business analysts or product people, and those who know the market and so on, and you capture that in your business model, right? The second word here, of course, is model. And what is a model, right? It's a conceptualization of something that's happening in the real world, something that's happening out there in the market that you want to capture and implement in your computer. And so that's sort of what a model is. It's sort of a limited simulation, if you will, because you're only going to pick certain aspects of that reality to be part of your application, right? And this set of things, this set of abstractions, this domain model, is the basis on which you're going to solve whatever it is that you're setting out to do, whatever specific problems for the customers you're trying to solve, right? And so this is where the business logic lives, and the quality of this model, in the end, determines the success or failure of your application. So, again, everything else that we're going to talk about today, if it doesn't fall in this orange box, we'll think about it as not being part of the domain, and we're just going to focus on how do we go about designing and writing code for this orange thing. So let's take a quick look of what this might look like from our past experiences in the object world, right? You've got this notion of nouns. People, when they kick off a project, will get in a room together and whiteboard and so on, and they throw out all the concepts of the domain. They throw out all the nouns that they can come up with, and then eventually from that arises a class diagram and so on, the relationships between these things, right? And the processes that happen in this real world, in the workflows, the things that get done, need to find homes, and these homes are the nouns. Each process belongs to a particular noun, right? And so the process of sort of designing a domain model in this world essentially boils down to making sure that the right nouns, first of all, you want the right nouns to be in this picture, and that these right nouns own the right processes. A lot of patterns and guidelines are, around in the literature to kind of help you achieve this distribution, right? And of course, in this world, nouns are classes or objects, right? And the processes are the methods inside those classes. And we know here today that object-oriented programming has issues that are not just an issue with as far as it comes to modeling, but also in the implementation itself, right? I mean, most object systems aren't quite what one would hope they would be, right? And not only is it a problem from, say, mutation and all of those standpoints, which we know how Clojure solves, but you also run into a modeling issue, because not everything is an object. And this is, of course, is a quote from the Kingdom of Nouns, from the Stevia gave a blog post of the same name, and you should read it if you haven't. But basically, it's you're handicapping yourself by thinking only in terms of nouns, and you're creating nouns just to hold processes, even if that's not a natural fit, right? And so in the Clojure world, of course, we are doing things differently, and verbs here are on equal standing with nouns. And so, of course, we know verbs are functions, and in this world, nouns are simply data. And verbs work on nouns to do things, and they transform the data. So if you think about the domain model in this world, it's really just a set of functions that transform certain data, Specifically, these functions are the ones that live here. So that's what I mean when I talk about the domain model, a set of functions that capture that same expertise that we talked about, that your business analysts have or your product managers have. And in this particular context, the purity of these functions matter, right? You want these to be clean, pure functions that have no side effects, right? They take some input, something that comes from an external source or something that's passed to you from another domain function and returns some transformed value, right? You don't want to have dependency on data storage here, because the fact that you're storing something in a persistent storage is really, it just happens to be that particular storage, or you may not even store it tomorrow, you may just send it off to another system, or it's an orthogonal concern. It isn't part of the domain, the fact that you're storing it in X, Y, or Z. You also don't want dependency on external sources. So for example, if you have third-party systems, you're calling third-party APIs, you're calling Facebook or whatever, you don't want your domain layer to directly depend on those things, right? You want some external entity reading that stuff off this third-party system and feeding you that in a clean way, right? So basically what I'm saying then is these functions are simply clean, pure Clojure functions and data structures. And when I say clean, we use that word a lot, you want to make sure that there's a lot of validation that's being done on this data that's coming in, right? And you want to validate most of this stuff outside the boundary of your domain layer, okay? And you may do some simple conditional checks, things like missing elements, the user ID is blank and so on. You may do, this is a string, or it's a date, you check all of these things. And if you have a more complex set of validation requirements, you can use a bunch of libraries that are out there. CLJ schema is something that came out of Runa, but there's a whole bunch of them, which let you declaratively specify, what is the nature of the data that you're expecting. And it will signal errors if it doesn't conform to that spec. You want all of these things done outside your domain layer. So your functions are clean, and they're only working on canonical representation of your domain data, if you will. So for example, if you're talking to Facebook and LinkedIn and Twitter, and all of them have this notion of a user, and they're sending it to you in different formats, obviously, then your domain functions should not have to know that, Twitter represents something this way and LinkedIn represents something this way. You want to convert that to a canonical representation, and that's what you operate on in the domain functions, right? And you also may have domain-specific checks. If you're an employee and not a contractor, then you should have signed certain paperwork, and if you haven't, that's a problem, right? Those kinds of domain-specific semantic checks that happen at a higher level obviously are domain-specific, so they live inside the domain layer, and they might be a sort of a small aspect of your validation that actually does enter the domain functions. And you shouldn't really have invalid or illegal states inside the domain function, because you should be, as much as possible, working on very clean canonical stuff. But if you do enter this kind of a situation, then that's a fatal problem. You want to report that in some way and go debug it, right? And beyond just throwing simple exceptions, you can now throw more structured things, which have a lot of information about what went wrong and so on. And then that information can be used at a higher level up the stack somewhere to manage what you want to do with things, right? So what we've got right now then is a bunch of functions that are all about the specific workflows and so on of the thing that you're trying to solve, a bunch of validations inside the layer, and then a bunch outside, and data is being instantiated and read off some sort of system or elsewhere, which is then being passed through this. And then down here, perhaps you've got things that are writing stuff back to the database, or something else that's coordinating all of these things. Those things are not part of the domain layer either. So where do all these functions live then, right? We organize all of this as a bunch of namespaces, and in fact collections of namespaces. So for example, in our world, we've got this high-level umbrella, okay, Zolo.domain, And all the namespaces that are related to the domain layer, we put them underneath of this umbrella, right? For example, stuff that's got to do with user and contact and message and so on, right? And if you look at this a little closely, right, they look a lot like class names. And that's okay, because that thinking, that organization principle actually does transfer over fairly well, right? Let's take a look at another example. The stuff that I'm talking about, reading off of third-party services and so on, we call it gateway, and you may have a bunch of namespaces in there. In fact, these are sub-collections. We have a bunch of Facebook-related namespaces and a bunch of LinkedIn-related namespaces and so on. So you want to keep things as cohesive as possible. Related things stay in related namespaces, right? You may have API collections. You may have service collections, your persistence collections, and so on. So how do all of these fit together, right? So if you look at some of these, we talked a lot about the orange piece, the domain, right? And we talked a little bit about the gateway and persistence layers. But you've got these things that coordinate all of these things together. So there's this notion of a service namespace or a collection of service namespaces, which basically are dependent on these other namespaces. So something that's living in the service layer would depend on gateway. It would also depend on domain. It would depend on persistence layer. So you could imagine something like some functionality being invoked in your service layer, say through an API call, which goes ahead and reads off of Facebook, finds that appropriate user from our database, loads it up, and then passes these two, cleans it up and passes it into domain functions that say update analytics or run some algorithms and run some scoring or whatever, and then the output of that comes out, and then it verses it back into the database. In all of this, again, domain is pure. It doesn't talk to the database, or it doesn't talk to Facebook or any of those things, right? And all of these namespaces depend on our favorite namespaces, the utility namespaces, which have things like these sort of collections of namespaces, right? The service, I introduced a term here. If you're coming from the OO world, the service layer is a fairly common term. And stuff that is in here is the stuff that doesn't really belong to the domain, but needs the coordination sort of stuff that we just talked about. It's basically the service pattern from the GRASP principles. So you might have a bunch of services that relate to the user, object, and their related ilk, and so on. Similarly, you may have a set of API namespaces that essentially have functions that are called when the RESTful APIs are being called. So when you read these namespaces, you want to just have the CRUD functions, for instance, right? Put, post, all of that. So you want to read these namespaces very clear. They simply delegate to service, and then service then talks to whoever it needs to talk to. Okay, so let's quickly look at the domain namespace that we've talked about so much. Here's some examples of the kind of stuff that lives here, right? Scoring relationship strengths, merge a contact's social identities, remind a user to follow up with someone, right? Suggest some contacts. If you think about these things, the pattern is there's a verb which is acting on a bunch of nouns, right? So again, a lot of times I hear, how do I move from OO to functional? And yeah, there is a whole bunch of things you need to learn in the functional way, immutable data and so on. But in the large, a lot of this stuff transfers over. We've talked about how we're designing namespace names and putting methods in there or functions there. And it's sort of very similar, what belongs where, that sort of thing transfers over really well, right? And namespace names, as we saw, a lot of times they're nouns, right? User, contact, right? They can be verbs too. That's the kind of tyranny that we don't have to suffer here, as we suffered in the OO way. Everything had to be sort of a noun. You had to create these things, and you don't have to do that here. You can call it whatever you want, but mostly they're nouns. It's a good way to think about it. And the high cohesion principle applies. You want to put related stuff in single namespaces. And namespaces have a few public functions, so you can document it's sort of self-documenting rather, what this namespace does to the outside world, and a bunch of private functions in there. And when you have a collection of namespaces like Facebook, it has a bunch of things. It has how do I read messages, how do I read a person's stream, how do I read a person's wall post or whatever. And then you have a core namespace, which is often the entry point into this sort of functionality, And you end up with a ton of core message namespaces. And so, thanks to Emacs, you have that way of figuring out which core you're talking about. A few more things, how do you decide if something's a function? Should I just inline this code or is it a function? I typically tend to err on the side of more functions, simply because function names are documentation. I don't want to have to read through what a function is doing to understand what the higher level thing is doing. I want to just read the name, and if I care, I want to read the implementation. So this helps in that way as well, right? Another reason to create functions is simply, oh, this is a thing I've seen somewhere else, and I should probably extract it. So you want your code to be dry. Nothing surprising there, right? So some other stuff like where do you put things? Now this is where we say, okay, does this belong to the domain, or does it belong to service, or does it belong elsewhere? So in the end, a good guiding principle there is if business folks care about what you're talking about, then put it in the domain. Otherwise, it probably goes elsewhere, right? And while we're at it, a whole bunch of test namespaces also live that mirror the structure. So all your tests can go in there. So this is what the domain model ends up being. It becomes the core of your app that's sort of really simple, low-level functions that mimic what's going on in the real world as far as a domain is concerned. And this lets you build up functionality on top of these functions and so on. And the idea being that you can manage higher level complexity through the simplicity of these functions, these simple functions, right? And so if you have more interesting things to express, then you can simply express them by building on top of this. That's kind of what I wanted to say about the domain. So process-wise, how do you start and how do you go about this kind of stuff? We start with the domain functions. When you think about building a new piece of new functionality, or you want to build an enhancement or any of that stuff, you start with the domain function, and then you start to add the other pieces, something that calls it and something that saves the output into the database or whatever, and then you sort of build out this from the inside out, and these thin slices are what then build up your whole app. All right, this puts the business in control of things. You start out with very much customer-focused, delivery-focused conversations. And as far as you can use testing to drive these kinds of things, these are pure functions, so it's really easy to test them. You can do unit testing, and you can drive this stuff with TDD if you choose to. And because everything is so simple and small here, you don't really need to do much in terms of mocking and stubbing, right? And you may want to do some of that at the higher levels when you're calling from service or from other things. And you can just use the simple binding macro or some other stuff that's out there in the community, some other libraries. But testing is obviously a key component to this and makes it really easy to do it. So, a few more thoughts on designing these things. Each function should do just one thing, right? You want, if the function's called do this and that, you want to split that up, right? This is also the same thing that comes from the, solid principles, the first one being single responsibility. And so a function that does one thing and a whole bunch of functions that do one small thing, have this notion of sort of being able to combine them in interesting ways. And the Unix philosophy of these small things that then combine to do more complex things. You also want your functions to be small. And when I say small, I literally mean lines of code, right? This is sort of some of the guidelines that I've found useful over the years, right? These are generally speaking, averages. Obviously some functions will have longer implementations. But in general, this is sort of a good guideline. Of course, you don't need any lines of code. You also want to optimize this for readability. If you have to sacrifice lines of code or anything else pretty much for readability, you should do it. Because in the end, the programming language is for the programmer. It's for somebody to read your source code and understand what's going on and be able to fix issues and so on, expand upon it. So this is very, very important. The whole point of talking about domain-driven design and everything that we've talked about is to keep the team agile, keep your ability to improve things on a day-to-day basis, to keep all of that alive. And a big part of that is, being able to understand what's going on. I've heard a lot of times in meetups and so on, these notions that someone reads a piece of code that's kind of complicated or clever looking, and they just feel that they have to learn more to understand it. It must be advanced or complicated in its own way. But really, it's just clever code. And so if you don't understand something that you're reading, you should demand simplification. I mean, we've started to demand simplification from our tools, Clojure, Datomic. We want our products to be nice and simple, apps, Apple, all of these things. Why not from the code that we have to deal with on a day-to-day basis, right? So please, this is really key. You want to change this sort of thing. These guidelines help, the no duplication, small functions, less lines of code. If you see things that are, these are good guidelines to help extract this stuff, and it does simplify code as well, right? And you want to not postpone these kinds of things. You want to do these things now because you're going to pay the cost of this complexity over and over and over through the project, lifetime. And this is where, the notion of collective code ownership is really important. And this is kind of a really key point. And, you may have a lot of pieces that are owned by specific subsets of your team. You may have somebody who's ultimately responsible for the API piece, somebody who's responsible for making sure the Storm jobs are running properly or whatever. But you cannot afford to have those kind of silos inside the domain model. This is what your business does. This is what your app does. So if you want to scale that up, you want to scale the team, you want to scale the application functionality, the domain model and the knowledge inside it has to be shared. So this is sort of what I had to say about domain driven. And let's talk briefly about design. So not terribly a lot of things to say here. But this sort of approach and this thinking kind of helps both in the large, which is, here's how I want to organize my app, and to the small, I want small functions and they do small things and so on. And of course, the end goal being this notion of being able to run quickly. And one other aspect of this that helps this goal is this notion of a ubiquitous language. And this is really quite simple. You want to have a common vocabulary that's being spoken between people that are technical and those that are not technical. And in fact, the same terms should flow into your code. I mean, and I have seen myself even now not do this very well, and we are having the same conversations every week with a designer, for example, and we internally in the technical side call it something, and he's like, what is that again? And we are explaining it to him, and he says, oh yeah, I get it, it's this. And then you have the same exact conversation the next day, because it's just the cognitive friction of calling the same thing different things. And if it's new, just make up a name for it, and everybody uses the same name, and the code also speaks the same language. And so that's what it means to have a ubiquitous language, and just, it's a pretty commonsensical thing, but often you end up with having a good glossary if you've got a lot of new terms and so on. And that actually helps in scaling the team as well. You've got one place where, we don't like documentation all that much, but this is a good one to have, a simple document that just talks about the various concepts in your system, right? Because you do want this, this core. You want this core of functionality, this set of functions that you can build upon, and they're going to form the basis of solving the specific issues that you're dealing with in the customer segment that you're going after. And not only does it make this a strong basis for building your application, but it also makes a strong basis for building a DSL runtime. Because you've built these things at a low level, you've modeled stuff that's going on fairly generically. You're not actually at this level solving a specific use case. You're just talking about, just like in the OO world, you're talking about, concepts, nouns, and so on. You're not really trying to say, oh, how am I going to invoice this guy, for instance. You're saying, I'm going to have an invoice, I'm going to have customers, I'm going to have a way of, so it's very generic. The same thing we did here. And so these functions, these low-level generic functions, will help you sort of implement this DSL runtime, if you will, right? So you can build this domain-specific language on top of this, which will then essentially script these lower-level functions. And this language can then be exposed to, obviously, your technical people, but also to the business. And they can write not just solutions that you thought of or you were asked to implement, but new stuff that they want to do for customers. Because again, this lower level stuff is all generic. Instead of, if a new requirement comes in that says, oh, we want to add this new feature, instead of hard coding it, you basically go back to the domain model and say, I'm going to now add a little bit of this and a little bit of that, and then at the next level, I'm going to combine them to provide what this person asked for. But these new things that you just added can also be combined in other ways with the stuff that already existed, and someone else can use it to provide some new functionality as well. So you get the combinability and of that. So you can solve not just the specific thing, but a whole class of problems in that domain. So what we have arrived at then is this notion of these pure functions that sit over here with specific validations being done at that level, external validations being done outside, and then a runtime that will help you be flexible in terms of what you can do with your application. And by no means is this I'm going to sit down here and decide how this is going to turn out. This is an iterative process, just like everything else is today. You're discovering your requirements, you're discovering your customer, you're discovering your business model, you're also discovering your domain model, right? And it evolves over time. Functions move around. You've got temporary namespaces that you're not quite sure, what they look like and so on. That's okay. You want to be able to do this quickly and eventually collapse these namespaces into wherever they end up being, right? For instance, we used to have a bunch of statistics or analytics namespaces that eventually just went away because after thinking about it a lot, we just realized, what? These things are truly domain functions. And you even have explicitly temporary locations for things. If you truly sit down and you have an argument and you ultimately decide you don't know where to put a function, you create a namespace for it. So when someone looks at it, you literally know, okay. And when you use, and you require everything, of course. So when you're inside another namespace, you're saying literally homeless / something, right? So everywhere you look at it and everywhere it's being used, you know it's a homeless function. So you want to run a campaign, adopt a function today, and you kind of move it over to its home. So some thoughts on this. The whole point of this thing is how do you manage complexity that arises from what you're doing, from the business that you're running, from the solution that you're providing, right? A lot of things that you do today to remove incidental complexity comes from the tools that we choose, obviously, but there's a ton that also comes from just doing things which you can just as easily not do. For instance, having long functions that nobody understands and have to read every time they want to know what's going on, badly named things, code that's strewn about. These are simple things that we can do to remove that sort of cognitive friction from understanding what's happening and being able to expand on these things, right? You want to just keep your domain logic as much a representation of those selected subsets of functionality as you can and remove everything else from it. And obviously you can't get any simpler than the domain itself. I mean, if you are, heaven forbid, if you're in the tax business, I mean, your domain's going to be complicated no matter what, right? But you don't want these other things to pollute it and make it worse. One sort of parting guiding principle on this is a good way to kind of keep this simplicity is to remember that you just are not going to need it. Don't add stuff to your domain if you're not going to use it. And this is really important. I mean, saying no is really, really valuable because a lot of times you end up with stuff that just doesn't get used. And you've got to maintain it and you've got to remember how it works and you've got to pay the cost of it being there through the life of the app. And so this is another one that I think is really important. Are you sure you want to implement this functionality? Push back on functionality even. If it's going to be just one customer or even two, in the long scheme of things, is it something that you want to pay the cost for, right? So we've talked about a bunch of things today. And it's just sort of, in the end, how do you stay agile, right? You've got these cool technologies, these good ways of doing things, but 2 years into a project, are you really as fast as a team that was, say, using Ruby or Java or something else? And in that analysis, the tools that you use certainly play a part, but they no longer are the dominant factor of your speed. And so you want to make sure that whatever it is you're doing, however you're building your apps, continue to keep your team agile, right? So these are some of the lessons I've learned over the last few years doing startups, but I know that they also work elsewhere, not specific to Clojure necessarily. So that's kind of really all I had to say, but I'm happy to have a discussion.